All right, we're working on some useful theorems today, and we are in lesson 8.6. And the book was really creative by calling this useful theorems. One theorem that we need to know is the conjugate root theorem. It tells us if a polynomial equation with real coefficients has a plus bi as a root, then a minus bi is also a root, which we've seen this a lot already. So let's say I had 4 plus 3i as a root. I also know that 4 minus 3i has to be a root as well. Our next theorem tells us, they literally called this one theorem, you are reading that right. It just tells us that every polynomial equation with complex coefficients and positive degree n has exactly n roots. And we're going to take a look at this right here on example 1. Example 1 says give the degree. So the first thing we have to remember is the degree of a polynomial and what that is. So remember the degree of a, the first term will be 2, the second term will be 1, and because this is x to the 0, the third term is 0. But the degree of this whole polynomial is going to be the largest of those terms. So the degree of this is 2. Now, if I had to figure out what the roots are, we know we could solve this to be x plus 4 and x plus 4 because we know the factors of 16 that add up to be 8 would be 4 and 4. And when you solve this, you learned that this is 4 double root. So there are actually 2 roots here. And what they want you to notice is that these match 2 roots and 2 degrees. So if I take a look at the next one we have a 3. So I know that the degree of this polynomial is 3. And again, I don't really have to solve it. I just have to know that the number of roots will match that degree, and there will be 3. Now, if I actually solve this, I can subtract. The reason why I'm doing this is a lot of people forgot how to solve this one today in class. So I'm going to subtract 125, and then when I take the perfect cube of each side, remember that x is going to equal negative 5. Negative 25 can be negative 5 times negative 5 times negative 5. And remember that this one, in this case, would be a triple root. We don't typically say triple root, but that's what's happening here. So really what this theorem is telling us is that the degrees and the roots will match. So let's look at the next one. This one is a little bit more difficult, and I'm going to take some time to write this out and show you the work on this. It says solve p of x is equal to x to the 4th minus 6x cubed plus 6x squared plus 24x minus 40 is equal to 0, given that 3 plus I is a root. Well, before the theorem, we had a conjugate theorem, and it told us that if 3 plus I is a root, I know that 3 minus I is also a root. So what I'm going to do with these two is I had 3 plus I and 3 minus I being my roots. So I'm going to take them into that x squared minus the sum of x plus the product. All right, so our first step in a question like this is we have to find the conjugate. So the first thing I did was I found 3 minus I. The second thing is I need to find a trinomial. So if I was to plug this in and add these, the i's would cancel out, and 3 plus 3 is equal to 6. And if I was to multiply these, 3 times 3 is 9. The outers are negative 3i, the inners are positive 3i, and my last term is minus I squared, which is going to be a positive 1, which gives me a 10. My next step, remember they gave us p of x is equal to, need to find my question, 6x, just kidding, it started with an x to the fourth. X to the fourth minus 6x cubed plus 6x squared plus 24x minus 40. So the next thing we have to do, and we have to long divide. We have to do it by long division. Because I have a trinomial here, I'm going to take this trinomial and I'm going to divide it into this whole thing. Now, don't let this intimidate you. If you know how to do long division, you're going to do awesome with this because it's actually a lot easier. And I'll show you why. First into first goes x squared. So when I distribute this, remember this has to go to 1, 2, 3. So when I distribute that, I get x to the fourth minus 6x cubed plus 10x squared. But when I change all the signs, notice that 2 out of the 3 cancel out. Well, that's pretty convenient. And we get negative 4x squared, and I'm going to drop the 24x and the negative 40 because it is a trinomial. And we do first into first. How many times does x squared go into negative 4x squared? Negative 4. Distribute. Negative 4x squared plus 24x minus 40. And when I change all the signs, notice I have a remainder of 0. So now our fourth step is we have x squared plus minus 4. So we actually have to factor and solve to find 2 more roots. So I know I can factor and solve. X squared minus 4 is equal to 0. This can factor to be x plus 2, x minus 2, and my 2 solutions are negative 2 and positive 2. So if we go back to the question, remember this was an x to the fourth. They asked us to find roots of this. They gave us 3 plus I. So I'm writing the answer right here in green. We found 3 minus I using the conjugate. I went ahead and used long division and I got x squared minus 4. And when I factored that, I got a positive 2 and a negative 2. And just like that, I have 1, 2, 3, 4 solutions, which matches my fourth root.